Hi everyone, welcome to the channel. My name is Saurabh Bhattacharya. I work for GoldenGate A team under GoldenGate Development Org at Oracle. I've been working with GoldenGate for over 2 decades, specializing in GoldenGate performance for Oracle RDBMS. The goal of this video series is to provide our users with some foundational insights into Oracle GoldenGate and then quickly go into in-depth technical discussion specifically focused on performance. Today's topic is integrated extract performance tuning and troubleshooting. Today is just going to be part 1. I intentionally wanted to keep the length of the video short so that it is easy to follow, concise and focused. More episodes on this topic will be published soon, so please stay tuned. Whether you're new in Oracle Golden Gate or you're trying to fine tune an existing deployment, I strongly believe this video series will help you understand the performance aspect of Golden Gate better so that you can get most out of the product. Last but not least, if you like the content of this video, please like and subscribe to the channel. With that, let's get started. So who are my audience? DBAs, DevOps engineers, Oracle Golden Gate users, whoever has working knowledge with Oracle Golden Gate are my audience. I would hope my audience understands the basic concept of what an extract is and its critical role in Oracle Golden Gate. And the purpose of this presentation is to showcase a methodical approach to diagnosing and resolving extract performance issues. I named today's episode Pipeline. Why Pipeline? You will understand shortly. This is a performance deep dive session. To get most out of this session, following are the prerequisite skills. Skill number 1 is database. Database are our endpoints. We are capturing from, we are applying into database. In this case, it is Oracle database, of course. Comprehensive understanding of Oracle database is crucial for quickly identifying and resolving bottlenecks. Next comes GoldenGate expertise. GoldenGate is our core product. To get most out of this session, comprehensive knowledge of GoldenGate is essential. And last but not least, operating system skills. Coming from a performance background, I strongly believe operating system skills are super important, especially if you are into deep troubleshooting and performance tuning. Many issues stem from the underlying system limitations and configurations. And please note, at the end of the day, all processes are subject to the constraint of the operating system. So where to begin and where to focus? I get this question a lot. Extract process is having high latency. How do I know where the problem is? Which component is the bottleneck? How to identify the root cause of the bottleneck and mitigate that to get more performance out of the system? The extract process that you see running in the operating system is actually a part of a larger pipeline. Troubleshooting starts understanding that processing pipeline. If you understand the processing pipeline, you will know how data flows through that pipeline, starting from redo log buffer all the way to the trail, right? So the knowledge of that pipeline is super important. To identify where delay or bottleneck occur requires clear knowledge of how data flows through that pipeline. And also the knowledge of interaction between database, Golden Gate, and the operating system layers are important. So here is a very basic picture diagram of an extract. I'm pretty sure you guys are all familiar with it. Here the extract process is running in the operating system. It has a configuration of parameter file where there is a list of tables. Based on that, extract is capturing real-time transactions from the database, buffering them into the memory until the data is committed. And once committed, data gets flushed into the trail. Very simple, straightforward, right? But the question is, do we know what happens inside the database, how data is processed inside the database, and where is the pipeline? To answer those questions, let's move on to the next slide. So here is the picture diagram of the extract processing pipeline end to end. Before I go in detail, let me explain the architecture first. Here the extract process is running in a hub. Hub is nothing but a virtual machine, right? The right side rectangle is where the extract hub is. The left hand side large rectangle is where the database server is hosted. There is a network between these two hosts. This is a high bandwidth, low latency network, right? So the extract process, like before, has a configuration of parameter file where there is a list of tables. Based on that, extract is capturing real-time transactions from the RDBMS, buffering it to the memory, and once committed, gets written into the trail. Now coming back to the pipeline is initiated by this process, extract. This is the process that initiates and creates the pipeline, right? So let me go in details now. When the extract process starts, it connects to the source database over a SQLnet connection in this case. When it connects to the source database to get real-time data, the foreground process that gets created inside the database is called the capture process. Again, let me repeat. When the extract process connects to the source database to get real-time data, the foreground process that gets created inside the database is called the capture process. The capture process in turn spawns a couple of background processes. One LogMiner builder, LMB in short, two LogMiner preparer by default, LMP1 and LMP2, and one LogMiner reader process, LMR. This is an example of a single instance Oracle database. That's why I have one LMR. If I have, let's say, two node RAG, I'll have two LMR. If I have a three node RAG, I'll have three LMR process, right? In this case, it is one since it is a single instance Oracle database. And also I'd like to highlight one thing. By default, there are two preparers. If you want, you can increase the number of preparers, but for most of the workload, we don't recommend increasing the number of preparers because you don't need, right? Unless there is saturation, there is no need to increase the number of preparers process, right? So just a quick recap of the pipeline. The pipeline starts with the LogMiner reader process, and the pipeline ends with the extract process flushing data into the trail. So inside the database, there are four background processes: LMR, one LMR, two LMP, LMP1 and 2, and one LMB. These four are background processes. We have one foreground process, which is the capture process. And then in the extract hub, we have a multi-threaded extract process running, right? So knowing the data flow is the key, both within the database and the operating system, right? So within the database, starting from LMR, LogMiner reader, we have LMR, LMP 1 and 2, and then LMB and the capture, right? And in the operating system, we have the extract process. GoldenGate extract processing starts at the recovery layer and spans multiple components, right? It starts with this component, is the beginning of the pipeline. LogMiner reader reads, redo, and archive at the recovery layer, right? And then it spans multiple components: preparer, builder, capture, and then finally the extract process, right? So in this pipeline, each of this component, they perform specific tasks, right? So in the next slide, I'll be discussing about task for each component. I'll break it down by component and discuss each component's role in the pipeline. So let's move on. So here's the Oracle database. What is the first component in the pipeline? LogMiner reader process. LogMiner reader process performs two specific tasks. Task number one, it reads, redo, and archive, right? Entire redo and archive is read. And once the data is read, the second task is to parse them, right? So again, LogMiner reader reads, redo, and archive. That is task number one. And task number two is to parse the data. Once the data is processed by LogMiner reader process, it then moves on to the next stage of processing, which is LogMiner preparer. There are two preparers, 1 and 2. What is the task of LogMiner preparer? LogMiner's prepares task is to filter in the data based on extract parameter file. Let's say in the extract parameter file, I have 20 tables listed, right? So extract wants to capture transactions relevant to those 20 tables. That's it, nothing else. Now see here, LogMiner reader reads the entire redo and archive. The whole thing is read, right? So when the data comes to LogMiner preparer only filters in the data that extract cares about, right? That's the job of LogMiner preparer. Once the data is processed by LogMiner preparer, it then moves on to the next stage of processing, which is by the LogMiner builder process. LogMiner builder process performs two tasks. Task number one is to sort the data that it receives from both these preparers in SCN order. That is task number one. Task number two is it also maintains LogMiner dictionary metadata. LogMiner has its own dictionary tables, and LogMiner builder's task is to maintain them by executing DML and SQL queries from time to time, right? Once the data is processed by LogMiner builder, it then moves on to the next stage of processing, which is by the capture process. What does capture process do? It reads data from LogMiner builder process, and then it formats the data in LCR format. LCR stands for logical change record, right? So plain and simple, reads data and formats the data in LCR format. It's a proprietary format, right? Once the data is formatted by capture process, it then moves on to the final stage of processing, which is by the extract process. So the capture process, between the capture and the extract, there is a network. data get pushed through this network to the extract process. Extract process receives data from capture process, both committed and uncommitted. The data that is already committed gets immediately flushed to the trail, but the data that is uncommitted remains in the memory until we know the future of the data, meaning whether it is committed or uncommitted. The moment it gets committed, it gets written into the trail. If the transaction is rolled back, it gets wiped out of the memory. The memory is managed by cache object manager, right? We call it COM. That's why I wrote COM here, right? So again, let's do a quick recap. The pipeline starts with LMR, LogMiner reader process. LogMiner reader reads, redo, and archive and parse them. Then data flows into the preparer process. Preparer filters in the data based on the extract parameter file. Next comes builder. Builder sorts the data in SCN format that it receives, and then it also executes DML to keep the dictionary metadata updated from time to time. Then the data flows to the capture process. Capture process reads and reformats the data in LCR format, right? Once the data is formatted by capture, then the data goes to the extract process. Extract buffers transaction in the memory until data is committed, and once committed, data gets written into the trail, right? That's the end-to-end processing pipeline. Now, in the next slide, I'm going to discuss about each of these component in little more detail, and we'll also discuss what kind of bottleneck you might see in each of these component when you're troubleshooting integrated extract performance. So let's move on. So what is the first component in the pipeline? The LogMiner reader process. What does LogMiner reader do? LogMiner reader reads a transaction from redo and archives and then parse them. What kind of bottleneck you might see with the LogMiner reader process? Let me tell you, based on my experience, hardly any, right? I mean, I've been working with this product for a very long time, and I can hardly recall how many times I've seen LogMiner reader itself being the bottleneck. Extremely rare, right? This process, LogMiner reader, straight out of the box without any tuning, is capable to handle very large amount of data. And most of the time, you'll not see any bottleneck. You can see other bottlenecks in the pipeline, but not with LogMiner reader process, right? But if you ask me in theory, yes, there could be bottlenecks, right? And let me give you an example, right? This is not a very realistic scenario. I just wanted to explain this bottleneck so that you know what kind of impact you may have if you have a bottleneck with LogMiner reader. So let's say LogMiner reader reads redo and archive from the recovery layer, right? Let's say the redo and archive are kept in a slow IO subsystem in the database. So what will happen is, if the IO subsystem is slow, LogMiner reader will spend most of the time trying to read data out of redo and archive, right? So this process, LogMiner reader, will be IO bottleneck, read IO bottleneck most of the time. So if this process LogMiner reader is IO bound, you will see the entire pipeline will slow down because this is the first component in the pipeline. If this component is struggling, the other components will not get data timely, right? So the whole pipeline will slow down. But the question is it realistic? Extremely unrealistic, because nobody keeps their redo and archive in a slow IO subsystem. Forget GoldenGate. If you are keeping your redo and archive for a database in a slow IO subsystem, the database itself will run slow, right? So it's not a very realistic example. I just wanted to explain the impact of a bottleneck. That's it. So let's move on to the next component in the pipeline, which is LogMiner Preparer. What does LogMiner Preparer do? It filters data based on the table list in the extract parameter file, right? So what kind of bottleneck you might see with LogMiner Preparer? Just like LogMiner Reader, you will hardly see any bottleneck with LogMiner Preparer. Hardly any, right? In the older version of RDBMS 11G, I remember if you configure too many prepare, like 4 or 5 preparers, you will see some latch contention, right? But since RDBMS 12C, those issues are all gone. So again, for most of the cases, you will not see any issues with LogMiner Preparer. So let's move on to the next component, which is LogMiner Builder process. What LogMiner Builder process does, it sorts data in SCN order, and it also maintains LogMiner dictionary metadata. For that, it queries dictionary metadata and it executes DML from time to time, right? So what kind of bottleneck you might see with LogMiner Builder? Again, in optimal condition, nothing, but I have seen this wait sometimes, not too many times, but sometimes. So let me explain that scenario. So LogMiner builder executes DML against dictionary tables and it executes SQL queries also, right? So let's say the dictionary statistics in the database is not updated. Let's say you forgot to generate dictionary statistics for the last 7 days. So what will happen is, let's say I have a dictionary table which is very large. It has a unique index, but because your dictionary statistics are not updated, optimizer picked up a wrong plan. Optimizer did not pick that unique index, right, for that large table. Instead, it picked up a full table scan or index range scan as an execution plan. So what will happen? The execution time for those queries will increase and the number of gets, buffer gets will increase. So what happens when your buffer gets goes high? But when buffer gets goes high, process becomes high on CPU because buffer gets are very expensive for CPU. Too many buffer inspection will spike the CPU usage. You will see this component will go 100% on CPU or close to 100%, and this component will become CPU bottleneck. If this component is CPU bottlenecked, right, everything in the pipeline will be slowed down because data has to flow through this component in the pipeline. This component is slow, the whole pipeline is slow, right? So please make sure you have dictionary statistics updated. If you have dictionary statistics are updated, you will not see issues with LogMiner builder process. Let's move on to the next component after LogMiner builder, which is the capture process. So what does capture process do? Capture process creates LCR or formats the data in LCR format. What kind of bottlenecks you might see with the capture process? Let me discuss the most common bottleneck that I see with the capture process. The most common bottleneck is with the network. So see here, capture process and then we have the extract process. There is a network between the database server and the server where the GoldenGate extract is running. So this network's bandwidth and latency are super important, right? So the bandwidth for this network has to be higher than what your workload generation rate is. And this is super important, right? If your bandwidth is compromised, you will see the capture process waiting most of the time to try to push the data across the network. So all these component on the left, LogMiner reader, preparer, builder will work so hard to get the data quickly, but capture process won't be able to push the data because you have a bandwidth limitation. So data will get accumulated in the memory in the database, right? So bandwidth has to be higher, at least higher than your workload generation rate, right? This is requirement number one. Number two is we also recommend having lower latency. If you have a high latency, let's say, I mean, that capture process is tolerant to some extent, like up to a decent number, like 30, 40 milliseconds. Let's say your latency is 200 millisecond. In that case, you will see the same thing. Capture process is waiting on the network most of the time, right? But what you can do is, as a workaround, if you have a good bandwidth but higher latency, as a workaround, you can increase the SDU size, right? SDU size is session data unit. You can increase from default 8K from RDBMS 12C release 2. I think you can increase it all the way up to 2 meg, right? If you make your packet size bigger, then even though you have a higher latency, you'll be able to use that bandwidth. Larger packet size will be able to use that bandwidth much more efficiently. The number of round trips, because you have now bigger packets between the capture and the extract, will reduce, right? And you'll be able to mitigate the network weight to a large extent. Again, coming back, two requirements: bandwidth and latency. If you have lower bandwidth, nothing can be done, right? You have to have higher bandwidth, higher than your workload generation rate. There is no exception to that. But if you have good bandwidth but higher latency, you can work around it to some extent using larger packet size, larger SDU size, right? So that's it with the capture process. Now let's move on to our final component, our favorite, extract, right? So what does extract process do? Extract process gets transaction from the capture process and buffers them in memory, right? Until the data is committed, and then once committed, it gets written into a trail. Now, what kind of bottlenecks do I see with the, you might see with the extract process, right? Most common bottleneck that I see with the extract process is with large transaction, batch kind of transaction, right? So even though customer runs OLTP database typically transactions are small, but I have seen many times customer runs batch kind of a workload in OLTP database. Not all the time, but sometimes. So what is batch kind of workload? Batch kind of workloads are workloads with commits far away, meaning the commits are at the end, right? The data is uncommitted for a long time. So as you know, GoldenGate buffers transaction in the memory until that data is committed. So if you are running a high amount of batch workload with high concurrency, what will happen is those data will get accumulated in the memory until the data is committed, right? So this memory that you see for the extract defaults to 64 GB, right? In Linux, right? You can increase it using cache manager, cache size parameter, but in order to increase, you have to have physical memory available, right? So when you're running large batch kind of a workload, please make sure that you have ample memory available to hold the batch in memory, right? That is the first recommendation. If you can hold the entire batch in memory while you're running batch kind of a workload, you'll have no issues, right? But what happens is if your batch is higher than your memory allocated, that memory will get spilled to the disk. And once memory gets spilled to the disk, extract will be using disk as an extension of memory. And when that happens, bad things happens. Extract will slow down. And if extract slows down, the whole pipeline will slow down, right? So it is very important to understand this impact. If you're running batch kind of a workload, please make sure you have ample memory allocated to the extract, right, to the server and then the extract, so that you can hold the whole batch in the memory, right? But if you cannot allocate that much memory, at least allocate a large amount of swap in a faster disk. That is, the second recommendation, right? If you cannot allocate that much memory, right? But the first recommendation is always to hold the whole batch in the physical RAM or the resident memory, right? What kind of other bottleneck you might see with the extract process? The second one is, let's say the extract process is writing data into the trail, right? So let's say these trails files are in a slow IO subsystem. In that case, you will see the extract is spending most of the time trying to write data into those trails because the IO subsystem is slow. If that happens, again the same effect, right? Extract will slow down, and so will the entire pipeline, because all this pipeline, the data will flow fast to the extract, but then extract is struggling to write data into the trail. That will create a back pressure and the pipeline will slow down, right? So please make sure you have faster disk where you're writing the trails, right? So if you're running batch kind of workload, make sure you have ample memory available to the server, and we always require faster disk, right? Just as a summary, if you ask me what are the most common bottlenecks that I see in the extract, only two, right? The most common bottleneck that I see with the capture process is the network. The network is not up to the mark. The bandwidth is less, right? So make sure the bandwidth is sufficient, at least higher than what your workload generation is, right? That is requirement number one. And then the extract process, long transaction, I see this a lot. If you're running batch kind of a workload, make sure you have ample memory available in the server to hold the batch, right? That's it for today. In the next episode, I'll be discussing about the tools I use with Oracle GoldenGate, and those when to use what tool to pinpoint bottleneck and the extract, and then to mitigate that, right? I hope you enjoyed this session. See you in the next episode. Thank you for watching.